One of the hard things in this chapter is figuring out when you have the case of independent samples and when you have the case of dependent samples. So two samples are independent if the sample values selected from one population are not related to or paired or matched with the sample values from the other population. The samples are dependent if the sample values are paired somehow. So each pair of sample values either consists of two measurements from the same subject, like before and after data, or each pair of sample values consists of matched pairs, such as husband and wife, mother and daughter, etc., where the matching is based on some relationship. So let's look at the different steps of our hypothesis test. These are the same steps that we've talked about before, just we're going to look specifically at how it works for independent samples and testing means. So our step one is still to determine our null and alternative hypothesis, and we want to start by writing down the claim or the statement. This one's a little bit different because when we go to translate this into an alternative hypothesis, we actually have two parameters. We have the mu1 and the mu2 that represent the two population means. We're still looking at using an inequality, so we have to figure out whether it's going to be a less than, a greater than, or not equal to. And here's where it gets just a little bit different. When we go to write down our alternative hypothesis, we're going to write it down one way, and then we're going to use algebra a little bit to change what it looks like. So first we're going to write the inequality with the mu1 on the left side and the mu2 on the right side. So we'll either have mu sub 1 is greater than mu sub 2, mu sub 1 is less than mu sub 2, or mu sub 1 is not equal to mu sub 2. The reason that we're doing that is because it's really easier to think about just how the two means are going to compare. Once we get that done, then the way we want to have it written in the end is with both of our means on the same side. So to do that, we'll subtract mu sub 2 from both sides. That way we'll have mu sub 1 minus mu sub 2 on the left side and 0 on the other side. We'll still have the same inequality symbol that we used up here. Once we get the alternative hypothesis written, then we'll do the null hypothesis just by replacing the inequality with an equal sign. So here's an example of writing the hypotheses. A researcher wants to know whether state quarters have a weight that is more than traditional quarters. He randomly selects 18 state quarters and 16 traditional quarters and weighs each of them. So first we're going to write the claim. The claim is that the average weight of state quarters is more than the average weight of traditional quarters. Our first question is, how can we tell whether this involves dependent samples, matched pairs, or independent samples? So if you look at the problem, there's no mention of pairs, and the most important thing in this one is that the sample sizes are different. If you have two different sample sizes, then there's no way it can be matched pairs. So this has to be two independent samples. So now we're going to translate our claim into an alternative hypothesis. Our two populations are state quarters, population 1, and traditional quarters, population 2. And that's just because that's how they're mentioned in the problem, that they mention the state quarters first and the traditional quarters second. We're going to use mu sub 1 and mu sub 2 to represent our population means. So what inequality should we use? The claim says that mu sub 1 is more than mu sub 2, so this translates to a greater than. So first we would write our alternative hypothesis as mu sub 1 is greater than mu sub 2, and then we would subtract the mu sub 2 from both sides to get mu sub 1 minus mu sub 2 is greater than 0. So our alternative hypothesis is mu sub 1 minus mu sub 2 is greater than 0. Our null hypothesis is that mu sub 1 minus mu sub 2 is equal to 0. Here's another example. Many studies have been conducted to test the effects of marijuana use on mental abilities. In one such study, groups of light and heavy users of marijuana were tested for memory recall. Test the claim that the population of heavy marijuana users has a lower mean score than the population of light users. So first write the claim as a complete sentence. The mean score on memory recall tests for heavy marijuana users is lower than the mean score for light marijuana users. Again, how can we tell whether this involves dependent samples or independent samples? Again, there's no mention of pairs in the problem. It just talks about comparing the two means. So in this problem, there's no before and after. There's no mention that that the two samples are related to each other in any way whatsoever. So to translate the claim into an alternative hypothesis, we could say the two populations are heavy marijuana users, population 1, and light marijuana users, population 2. And again, that's just because they mentioned heavy marijuana users first in the problem, and we mentioned them first in the claim. What inequality should we use? The claim says that mu sub 1 is lower than mu sub 2, so this translates to a less than. So we would write our alternative hypothesis first as mu sub 1 is less than mu sub 2, and then rewrite it as mu sub 1 minus mu sub 2 is less than 0. So here's our alternative hypothesis, mu sub 1 minus mu sub 2 is less than 0, and our null hypothesis is that mu sub 1 minus mu sub 2 is equal to 0.